Hi everyone, this is a quick walkthrough of project number one. I just want to provide you with a little bit of insight into how the project is laid out and what it's going to look like, so when the students start asking you questions, you'll be able to easily provide answers for them. So what I have over here is I have the project itself, the PDF on the left-hand side, and on the right-hand side I have the sandbox. So largely this is similar to the project number one that was done last year. Much thanks to the group that did that. And of course, special thanks to Danny. I apologize for this being late, but I was struggling with the R code on numerous occasions, and Danny helped me straighten all that out. So we have the history here. This was all from last year. And where we start then is with our data frame. So the data frame for this project is called Ebola All. And the first command the students are going to execute in R is the head command, which they've seen before in the text, and that just provides the first 6 rows along with all of the column names here. And so the students will see something that looks exactly like this. I've provided a table which outlines what all of those column names are, along with descriptions to hopefully reduce the amount of confusion. The first question is, and all of this of course will be in Gradescope. The first question here is just for them to include a plot of the date versus the Guinea cases in the data frame. And so then it asks them, hey, what does this look like with respect to our pattern book functions? And I'm expecting that, maybe they'll say Gaussian, maybe they won't. Quite frankly, the raw data here are kind of like a shotgun. They don't really look like much of anything, but that's what I'm looking for the answer, right? We want to use real data. We want things to be a little bit messy, and that's what this first image is all about. So then there's some conversation here, and again, thanks to the group from last year, this is just about the challenges associated with using real data. And the next command the students are going to use is this one here. This is a copy and paste command. So they don't need to understand it. All they need to do is put it in, and it's going to provide them with an excerpt from the actual data frame. And the question associated with this is just for them to look through and find stuff that some report that seems kind of out of place or ridiculous. So let me give you a couple of examples. Here's a report from October 29th, and you can see here the Liberian cases. We have 1,860 cases with zeros around it. So no one believes that's a legitimate data point. In fact, that's just a catch up from errors that were made, going back in history, who knows how far. But that's the kind of thing that I'm hoping that they'll see. Or the following, on Halloween of that year, we have nothing being reported from anybody except the number of Guinea deaths is increased by 21. And then the next report follows almost a week later on the 5th of November. So look, any of these types of things, there's no right answer here. This is just to have the students look at the data frame and understand a little bit about what it says. For the students who are interested in the details of this print command, I've provided, this is not required material at all, but I've provided some explanation as to what's happening with the print command. I don't want the students to be overwhelmed. So going back to the kind of shotgun picture that we have here, what we're going to do next is talk a little bit about data wrangling, and that's the conversation that is here. We're going to create a new data set. Students don't have to do this. The data are already set in a new data set, but it's an explanation as to what's going on. And we have a new data frame called Ebola Guinea. And the Ebola Guinea, again, they're going to execute the head command, and they're going to see something that looks like this. Again, there's a table which explains what the column headers mean, so the students are not lost as to what's happening. And once they have seen this and read through the data wrangling portion of it, then we'll start into our analysis. And the third question here is just a repeat of the first question using the averaged data. So something that's a little bit more tractable for us to be able to use. And now we can clearly see that this does look like a Gaussian. In fact, it looks like it might be a combination of 4 Gaussians. And we're not going to use 4 Gaussians. We're going to only use 2. But it's something that's a little bit more than just slapping one single Gaussian on top of this. And my hope is that they have the command here, so they're just going to copy and paste this command into the sandbox, and I'll show you what that looks like in just a minute. But they have 5 parameters associated with 2 means, 2 standard deviations, and 1 amplitude parameter that helps to reduce the complexity of them needing to guess what the amplitudes are for these 2 different Gaussians. So there's also an initial example here so they can execute it and get a feel for what that looks like. Let me show you what that looks like in the sandbox. So this first Gaussian, double Gaussian model looks like this. And the idea here is for the students to use the pipe operator in order to put together the scatter plot along with a line plot or line graph of their model. And then we expect them, question number 4 is where things start to get a little bit more involved. We want them to iterate on what's happening. So to do that, they're going to just come up here and change the parameters. So let me just give you a couple of examples of what this looks like. So right here, we have one way that the 2 Gaussians can be meshed in order to match up with the data a little bit better. That one I will expect to see regularly. Here's another one that I would expect to see with the 2 Gaussians. You know, there may be people that kind of model this initial start and then kind of lump all of the rest of this together in a single Gaussian. There is no right answer. Whatever they want to do, it's fine, right? This is all about exploring and having them get in with the tool and use it. And so all of these things are great. Once they've played around with this, then they're going to give us kind of what their best guess is, if you will, and they're going to provide that as the answer to question number 4. The next section is called data smoothing, and what we're going to do now is we're going to introduce the relationship. We're going to review, because we've already talked about this in class, the relationship between the Gaussian and the sigmoid function. And what we're going to do is use the cum-sum command, the cumulative sum command in R, in order to accumulate these report by report cases into a moving total. And I have an example here of cum-sum for students who are not familiar with what a cumulative sum is. And then we're going to use 2 commands. And again, this is copy and paste. The students don't need to create this from scratch. They just need to copy and paste these commands in. The 2 commands they're going to use are the mutate command, which is, I learned, the R command for add a column to your data frame, and then the cum-sum command. And here's an example. They're just going to copy and paste this directly into their sandbox. The result of this is going to create a new column which has the cumulative number of cases for Guinea. And then we're going to ask them to plot that. First, they'll use the head command to take a look that there has been a new column added. So this is what we have, and you can see the new column over here from the head command is this total number of cases, which is an accumulation. This graph is the answer to question number 5. We want the students to have this cumulative graph here. And then what we want to do is have them, now we get into really the hardest part of the project. We want them to go back to their model and accumulate the data using their model. What's going to end up happening with that is they're going to, again, use but the mutate command and the cum-sum command, this time on their model. And they can use the head command again in order to see that their new column has appeared. And then they're going to use the GF point and the pipe operator in order to combine the 2 models together like this. So in this case, the model, which is the black line, accumulated at the particular days, gives the blue set of dots. So the black set of dots is the same as the original Guinea total. So what we want them to do is look at this and now just turn the knobs again on their model. and to try to come up with something that fits a little bit more closely with the accumulation piece here. Again, it kind of depends, right? If they use the model that includes the initial part of this, they'll get a good match initially, but then it will kind of fall apart here in the middle. If instead we go back and we use the model that matches a little bit better for the middle part here, then that matching is going to improve our model through the middle in the accumulation, but of course we lose the fidelity in the initial part of this. So that's really the main part of this. After question number 6 and their initial look at this, we want them to iterate again through the process. So exactly as I've demonstrated, they're going to change the parameters in the model, and they're going to look at how the accumulation for their model matches with the actual accumulation for the data. And you know, this is the part where I suspect they'll have the most difficulty, and this might be where you need to help them out a little bit. Question number 7 is just a wrap-up question that says, hey, you know, once you're finished with your modeling process, you know, explain a little bit about how you were making your decisions and why you decided it was finally time to stop. And that really ends the most challenging aspect of the project. So the remaining 3 questions, there's a total of 10 questions here. The remaining 3 questions are more of the kind of thought-provoking questions. So questions 8 and 9 have to do with understanding how the modeling fits in with our knowledge of the fact that if we have a disease spreading, that the infection rate follows a single Gaussian. And so the question is, why is this a better model with 2 Gaussians? You know, what's happening there with the spread of the disease through Guinea that makes it so that we have 2 Gaussians is better than a single Gaussian. The question number 9 digs a little bit more deeply into adding additional functions to our linear combination. What happens if we add a 3rd or a 4th Gaussian, right? Do we think that's a good idea? What are the challenges associated with that? Again, just more kind of thought-provoking on what it is that we'd like to see from them. So if they do this, right, it would be great. There's no conversation here about fit models. So if they apply the fit model for the 2 Gaussians, that's fine. If they expand the 2 Gaussians to be 3 Gaussians, you might want to help them with that if they take off in that direction. And let me just give you a quick demonstration of what I ended up with in MATLAB. So here's my crude curve fitting device here. This is a Monte Carlo, and this is what I get out with 3 Gaussians. Notice that the first Gaussian helps with this initial condition here, and then the second and thirds are used for this middle bandwidth part. So if they pursue this, and they'll end up with a model in the accumulation that looks like this one here. So, you know, that's just bonus material. If they do that, fantastic. And if any of them are interested in doing that, it's not a big change to what we've done. All they have to do is add in 1 more Gaussian and then make sure that the coefficients on the inside sum up to 1. So if we come back here and look at this adjustment, the 15,800 is still on the outside, and then the sum of the 3 coefficients in front of the Gaussians has to sum up to 1. The last question has to do with, hey, now that you've done this entire process, let's go all the way back to the beginning and think about how we could have done this better. And, you know, again, this is wide open. They can say whatever they want. I'm thinking some of them will say, hey, you know, we kind of wasted our time doing this Gaussian. We could have just gone straight to fitting sigmoids to the accumulation of the number of cases. And sure, that's great, along with any of another you know, host of other answers that are possible. So this is what the project looks like, and I will put all of this material out into the assignments channel. If you have any questions, any concerns, everything will be out there. Please just let me know. Type something into Teams and we'll try to get it fixed as quickly as possible. Remember, there will be a grade scope that goes with this, and I'll work on that some tomorrow. Thanks very much.